Okay, welcome everyone to Robot Builders Night Virtual for October 22nd, 2024. We've got the usual format, half a dozen contributors who have things to report, and then we'll go to open mic. I think most of you know that this Saturday we will have a meeting at the DPRG monthly meeting at the Dallas Makerspace. We're going to watch the Canadian section of DPRG compete two robots, and hopefully they will do well. We're excited to see what's going on. They're both going to tell us how they're getting on tonight, and then we'll have a show and tell for whatever Robo Columbus relevant, or maybe other topics, whatever you feel like sharing at the meeting. And then November 23rd is Robo Columbus itself at the double secret location in Farmersville, Texas. But we hope you can make it if you're watching this, and please send, if you want the address, send an email to secretary@dprg.org and you'll be given the address. It's just a matter of respecting the privacy of the landowner. With that, let's kick off the queue with Pat.
Hey, everybody. I've been frantically working towards getting my robot ready for Saturday. It's the Canadian presentation for the Robo Columbus. Been making some progress and making some headaches. So I'll give you a video. Let me share my screen. So here's the run in manual mode. You can see the blue light is my target. And as I'm driving around in a straight line, my target...
We're not seeing any video, Pat.
Oh.
We're seeing your Explorer.
How's that?
Nothing.
It looks like you stopped presenting.
You stopped presenting?
Yeah. I don't see. Does anybody else see his presentation?
No, nothing. There's nothing.
Okay.
Stop sharing.
What? Let's try this screen to share.
Explorer.
There we go.
Explorer, yeah.
Okay.
So here you can see I've got right there, I don't know if you can see my mouse.
I love that.
That's the direction of my target. So it's working with my compass and the GPS to give me a direction to head in. And so far it's working. It's pointing in the direction it needs to go. As soon as we get the motors going, you can see it jump around. So I'm driving in a straight line.
Yeah, that ain't right.
And it's all over the place. It's like all around. And so it's driving me nuts. And it gets even worse because in autonomous mode,
yeah,
it just tries to, hey, where am I going?
But where's that target coming from?
So the target is coming from GPS coordinates. And I don't know if I got a better view of, right on the end here, on the left side of my picture, is my compass. So I've tried to locate it away from, I'm quite a ways up. I'm about 20 inches above the motors. And I have wires for my GPS coming down my mast. Just a little tiny USB cable. So I kept it back away from that cable as well, because when it was right up against it, I found that my compass was off by about 20 degrees. So I backed it off. I got good readings on my compass. So I said, well, maybe it's because I haven't calibrated my compass. I haven't calibrated the magnetometer in the compass. So today I dug up a routine. I found Kalulu had a routine for the LSM 303, and I ran it through the steps and then put in the values into my program for calibration with identical results.
But
so
when it was stationary, it wasn't as bad, right?
when it's stationary, and I don't know if here's where I started stationary, and it's hard to see, but right here you can see the LED, and it's pointing in the proper direction. So it's telling me I'm in the proper direction, and that's where I'm getting. So I can I don't have the program running on the robot right now, but when it is running and when it is stationary, I can turn the robot right around and I follow through exactly where my target is. So it's just when the motors are running. And
Have you looked at the power supply rails? Is there lots of noise on the 3.3 volts and ground?
I don't have a scope to check it.
Oh, okay.
Are you recording the data coming out of the compass and the GPS such that you can kind of plot it as it changes over time?
No, right now I'm not plotting it, but it's obvious by the visual fact it is changing all over the place.
I'm just wondering which one is bouncing around, right? Is it the compass or is it the GPS doing crazy things? I mean, the GPS doesn't give you orientation, right? It just gives you...
It just gives me distance and direction. And you know what I mean? The distance and direction, I'm updating a second.
I think what Chris is getting at, Pat, is how far away is the target? Like, could it be being affected by GPS jump?
Oh, no. The target doesn't move that far. The target is 50 meters away.
Okay.
Are you using serial or I2C?
I am using I2C in my compass.
Okay. Any chance there's interference in the wiring?
If it was, I'd see some CRC errors.
Yeah. Okay.
And I'm not seeing CRC errors.
Yeah, I think you're going to have to find a way to visualize that data, which, well, you're kind of sort of doing with your LED there. But I mean, you know, XY kind of plot over time. The other thing that would be interesting, right? So in the first video you showed, it started jumping the moment the robot started moving, right?
Yes.
I wonder if we could do an experiment where you put your robot on a pedestal, you turn the motors on, you start moving the motors, but you're still stationary. What happens in that case, right? Are the motors causing interference? Or is the movement of the robot making it so bad?
That's a good idea. I can do that here, right where the robot is sitting. I can fire it up and see what's going on.
Yeah. And have you tried moving the robot, just picking up and moving it and see if the direction changes?
Just holding it still?
No, I mean, pick it up and just without running the motors and just move it and turn it.
It follows the target. So the LED
okay.
will tell me where the target is when I do that.
Yeah, so that kind of tells you it's the motors.
Yeah.
So that's what I'm thinking, but I'm not going to get new motors by Saturday.
Yeah.
Well, considering
is the blue light the compass or the GPS or both?
It's a combination of both. So it's the compass tells me the pose of the robot.
Yep.
The GPS tells me distance and direction to the target. And the LED is the math between the two to say, hey, point in this direction.
So to help with or to riff on Chris's idea, what happens if you play the two lights at a time trick and you put the one at the front of the robot to show or even 3 lights. You could have one light that shows where north is per the compass, and then you can have another one that shows the combination of where the target is. Well, I guess you only need the 2 then, because if you know where the north is per the compass, at the same time you can see the direction of the target, then you can tell which one's moving. See what I'm saying? Just like 2 LEDs at a time. That's what I've done on my rings.
Okay,
like
yeah,
that.
I could send a second LED.
Yeah.
Yeah, make it
And-
red. So if that red one's bouncing around, right, then okay, your compass signal is bouncing around.
Kind of isolates it. Yeah.
Can you clarify when you said that you have the compass is used for computation of the bearing based on the GPS current position and the waypoint, but then you also said GPS is used for calculating the bearing based on its position. So how exactly do the compass and the GPS play against each other?
It's the GPS is giving me the direction from the center point of the robot, the cardinal direction. The compass is giving me the pose of the robot.
Right.
And I use the difference between the 2 to give me a turn degree.
Are you doing that computation though on a every sample basis, or do you, for example, maybe average the compass for a while, average the GPS for a while, and then do the math, so that in case either one of them is jittering around, you're not going to like exacerbate their jitter by doing a difference on a single sample?
Yeah, my GPS is read once a second.
Oh.
So I don't need to know my GPS position that often. We're not going 60 miles an hour. We're going a foot per second or 30 centimeters per second. So it's not going to change that much. My compass is read 20 times a second.
All right. So that says if you play your video again, then that tells us right there that
it's a compass.
Updating the GPS once a second, that light is bouncing around much more than once a second. So
oh yeah.
So it's the compass that's bouncing around.
It's definitely, I think it's the compass.
But at the same time, it's not random, right? Because it tends to stay in that 1/4 of
it
quadrant.
Tends to stay, in the northern hemisphere.
Right.
Essentially, for the most part, it stays, from east to west on the northerly side.
So just as a kludgy quick do something to make progress, maybe just averaging the compass before you do the math could help.
Well, presently I take 80% of my old reading plus 20% of my new reading.
Okay.
And that's how I average it out, basically, doing that.
Samples.
Yeah. So, and you constantly update your old sample and you keep doing that. So it prevents the wild swings, but it's still, 20 times a second.
Pat, quick question. In the example of your video, which direction is your robot nominally moving in?
In the autonomous one?
In the video that you're showing, you have a compass reading that's
Yes.
bouncing around even though you filter it. Which direction are you trying, is your robot actually measuring?
Due north, I
Isn't it
guess.
north by any chance?
That's in the westerly direction.
Okay, because I'm using the exact same compass you are, and I've looked at several filtering strategies and looked at what a few other people do. The problem is if you're in degrees and you're using conventional compass degrees, the filtering of the transition between 0 degrees and 360 degrees is complicated and will cause a massive jumping.
Yeah, that's a good point. You could easily mess that up and average, like 359 and 1 and get 180 degrees.
Okay.
thought. I don't know what your code looks like, but just a thought.
No, that does make sense. I'm not going in the north direction, but
Yeah.
I can see where it would make a difference.
Yeah. You are using a filter, so you might want to take a look at where that fits in terms of your degree computation chain, just to see what might be happening.
Just based on the motion of the platform, it's obviously not trying to follow those. It seems like it's heading in pretty much the same direction. So
Well, the video that's playing presently, that is under a radio control,
oh, okay.
Manual control.
manual control.
But Pat, if
No,
the,
you showed the video where it was autonomous, where it was like literally, I mean, oh, where am I going? Where am I going?
Yeah, so autonomous, it's all over. So now it's turning
So it is
north,
trying to follow it then.
Yeah,
It looks
and
like.
now it's turning back towards the west. Then it's turning north again, and then it's turning west, southwest.
Yeah. The reason I'm curious now there's a lot of variables here. For instance, are you accessing the compass from your Raspberry Pi in Python?
My compass is tied through an Arduino Nano. The Nano is doing the reading. And,
Gotcha. Okay. All right. So
and
you've
passing off my serial.
So have you written your compass access code and your heading calculations are all running in C++, I presume?
Nope. I just read the compass in C++ on Arduino, and I hand off everything to Python.
Oh, that's interesting. Okay. I'm using the exact same code. I'm accessing, doing everything in Python, and had a hell of a time finding any existing libraries that made any sense. And after 2 days, as I mentioned in my email to you, after 2 days, finally sat down and wrote my own code, and it's running wonderfully.
And you're running it with the motors, and it's working?
Oh, yeah.
Tom, for a small fee, will you share it with Pat? Or?
And, are you willing to share your code?
Yeah, if it makes sense to you, it's MicroPython.
The MicroPython to Python isn't that hard to port.
Yeah, I'm sure I can do that. I'll email it to you later on today.
Okay, great. So that's been the dilemmas. So I think it's my compass that's misbehaving. I don't know if putting noise suppression on it, putting some capacitors in there was going to help that much.
But can you rule out the GPS for sure? I mean, based on the way you're explaining how you're doing the math, right? So if the GPS were to bounce around, would that produce the same symptoms?
If the GPS were to bounce around, it will produce the same symptoms, but I'm 50 meters away from the target, and my GPS updates once a second.
Okay. Just one more question, and this may be kind of a dumb question. In the research I had to do on the compass, the LMS 303, I discovered there are 5 different variants of that same compass chip, and they're not the same. They're not interchangeable. Have you confirmed which version you've got?
So DLHC was the one that I believe I bought.
Yeah, and that's the one I've got, and I've confirmed that. But there's a lot of code for the other variants that's floating around out there, and most of that code's in C++. So just be aware.
Tom, I think you might be running down the wrong track here, because he was showing his robot working when the motors weren't moving. I mean, the compass seemed to be working when the motors weren't turning.
Good point.
So it seems like, if I were you, I'd isolate down and try just the compass and mount, use as short a cable as possible. Make sure it's not some interference with the cable, and just try running it with the motors without the actual robot moving, like Chris said, put it on a platform and just see if it gets a good reading that way, and kind of work your way up. Add more and more things and make sure everything's working before you add another variable.
Okay, well, I'll fire it up today, right, with the compass running and the GPS running with no motors.
Yeah.
And I'll be able to show what I'm getting back as readings on my I'll give you the target info, which is what I'm sending to the LEDs.
Yeah, you might need an electrical filter, just like a resistor and capacitor, to smooth out the power supply to the device. You might be picking up EMI on the.
But
You may have brownouts.
It can go in by the low impedance drive lines too, right? So
What?
the noise could couple into the compass chip not only through the power, but even through the low impedance output drivers of the compass. So it could couple in anyway, a lot of ways.
Yeah, it could be having brownouts too.
So Pat, here's a crazy thought for you, because time is short. So let's say that you can convince yourself it works pretty good without the motors running, but then it gets a little wonky when the motors are running. So stop the motors, get your bearings, turn in about the right direction, and put the blinders on. Go by encoders for a while.
Brilliant.
Stop for a bit.
I'm considering doing exactly that as a backup. Is that okay? As soon as I stop, my compass is back on.
Yeah.
Case where less data sampling is better.
I guess the other thing you could do is the shotgun approach. You could put like a 0.1 microfarad cap across each of your motor terminals and across the supply lines of the compass, and see if that makes it perform any better. That's what it seems like it is. I mean, if you stop the motors and things work much better, then.
Or just like wire a
Pat,
standalone battery.
I agree with Ray. There, it's a simple fix, but it'll probably cut your noise way down. Is you put a 0.1 capacitor between the two leads of the motor, okay? And then you take from each lead of the motor to the body of the motor.
To the case.
That sometimes can be a little pain, because sometimes that doesn't want to solder well. But you can, you might have to do a little pickling on it and then solder. But once you have those three capacitors in place on all the motors, that'll cut a lot of the motor noise down. And I think what Carl said is, if you could put a small impedance inside of the power supply line, you might or a capacitor is on the power, that probably might be useful too. And the other idea about it browning out, that is how are you supply? Are they on separate 5-volt supplies?
So my motors are on direct to the battery.
Okay.
And the Raspberry Pi and all of the other stuff are on a switching regulator.
Okay.
So I have a 10 amp switching regulator in there.
Gotcha. Okay. All right.
So, and it has a couple capacitors in it. Well, it's got several capacitors in it. I can't see the size. And it's got an inductor in there as well. It's switching power supply.
Okay. Sounds good. But you might try those capacitors on the motor. I've had situations where I'd get random stops. Board would just basically stop. And once I put the capacitors in, all that problem went away.
So when I run it with the radio control, with the controller, it runs great, doesn't stop, doesn't turn, doesn't. So that's where I think that.
But it's not depending on the Pi, then, is it?
It's the radio control goes through the Pi. It's
okay, all right.
Just a PS3 controller to a USB dongle on the Pi.
Got it.
And that's all. That's working good. When I tell it to go forward, it's going forward. It's not stopping. It's not hesitating. And that's where I'm not 100% sure that it's electrical noise, because it seems to follow the commands given with the remote. But the compass seems to be, no matter which way I'm going, the compass is erratic, whether it's with the remote, whether it's autonomous.
Is it on the top of that big shaft?
The compass is, I don't know if you can see it in this one. So there's my compass.
I'm not seeing anything. I'm not seeing anything.
Oh, I'm not sharing.
Yeah.
Let me share again. So it's
Oh,
on.
it's on that
the-
cross piece.
Yeah.
Okay.
So at the top, I've got a GPS with a ground plate,
Mm-hmm. Mm-hmm.
and it's the wooden plate. The wooden crossbar is about 20 inches above the. It's actually about 20 inches above the top.
Should be plenty far away.
Yeah, that looks far enough away.
Well, from
I wonder about your I2C bus. What's on IC squared? I2C,
That is the only thing on it.
the compass.
I added an additional hub to extend my I2C because I was too close to. I figured I was too close to the motors, and decided, okay, let me go a little farther.
Hmm.
So I'll get it going statically here without the motor spinning,
Yeah.
and I'll do another little presentation later.
Okay.
In the meantime,
Do you have RTK GPS or regular GPS?
just a regular GPS.
Okay.
Up north, we don't have any. There's hardly any RTK stations up here. I'd have to provide my own.
So Pat, you said you got CRC checks and the like. So do you have logic in your code that rejects corrupted data from the sensor?
So it's just been spitting out, when it gets a CRC check, it's been spitting out the data as a CRC error.
But do you then compute math on it anyhow, or do you skip the computation then?
It was skipping it. I've pulled it out because I was still getting it. Even if I pulled it out, it was still getting a CRC error and it was printing out.
Just another dumb question. You have a scope, I assume, Pat?
I do not.
Oh, okay. I was going to say, put a scope on those wires and see what they look like.
Yeah.
So
How do you live with yourself without a scope?
Yeah.
that's one ho, baby. That's
Or two.
Yeah.
Mark
Thanks,
Tony
Chris.
didn't have a scope.
Fall to the second, on the roof on the second floor and do a nosedive. It's a scope has been on my list, but
Well, maybe later in the meeting you can report on whether spinning the motors causes the compass to jump around.
yes.
Okay.
So I will give you an update in a bit.
Good luck. Okay. Tom.
Okay, I'll give you a little quick informal. I don't have a video. I'm sorry. I was outside for an hour this afternoon. I should have taken a video. Just a quick look at the current state of the machine, if you can see it. And I assume you can see it. So lots of pretty lights and a long, long mast, and there's a compass up there on the top with an I2C line running down inside the mast in an insulated cable. It's actually an old Apple charging cable. They're very nice cables. On
Can you
board,
hold it up a bit higher, Pat? Tom? Hold
Pardon?
it up a bit higher. It's not really on camera.
how's that?
Yeah, that's better.
The wooden gadget sticking up the front, the right-hand side, if that's the same place you are, that just has some distance sensors, ultrasonic, IR, LiDAR, simple stuff I haven't done much with at this point. They're working, but I don't have them tied into anything yet. On the back side is my arms get tired. On the back side, you can see the antenna for a GPS. It's a U-Block 6M, so it's just GPS, not GNSS. I still get lots of satellites. I get good looking latitude and longitude out of it. What else is in here? There's a radio receiver. I had mentioned before, I have a 3-channel RC control system here that allows me to have wireless remote control and also a kill switch to allow me to put it in auto mode or to shut it down. On the back, I simply have some an LCD display and some push buttons and some LEDs and an LCD. So it gives me a little bit of a quick indicator of what's happening. This thing runs on an ESP32. There's a small amount of voltage control stuff and voltage regulators for various purposes as usual. Running on a 3S 11 whatever volt battery. There's a battery compartment sitting underneath. You can see the nice silver door I had to add when I had to put in bigger batteries. So there's a nice battery compartment. What else is on here? I have a wheel sensor on one of the back wheels. It works, but it's too low resolution to do speed regulation. So there's no speed regulation on the motor. This thing is rear wheel drive only, front wheel steering. And there's a servo to steer it, although it doesn't give very much useful range. So pragmatic steering control simply says go straight, go left, go right. Doug had mentioned to me that's probably where I would end up after I was so pleased with myself when I added the servos.
The voice of experience.
Yeah. The thing has a top speed of probably 10 or 11 kilometers an hour, so it's a little faster than I wanted it to be, but that's fine. I have got the GPS working great. I have the distance sensors working, but not tied into any avoidance logic yet. I have the compass working well. I've spent the last few days on the compass, mainly because there aren't any libraries for it in MicroPython, and it's not that common a compass module, as it turns out. So I wrote my own stuff. I'll send it to Pat later on. The compass stuff is working very, very well. The LM303 is both compass, it's both magnetometers and accelerometers. So they all get calibrated. And I've written calibration software as part of the package I wrote. And I save the calibration results in a JSON file on board the ESP32, which is automatically loaded every time you boot it up. And that's a real plus. I admit it's the first time I've used JSON. I should have started using JSON a lot sooner. My God, is it simple and really nice to look at. And the ESP32 has MicroPython has a very nice, straightforward file system included within it that makes everything trivial. So I'll probably be saving a lot more data because I got lots of prompt space there to write it in. I've implemented pitch and roll on this thing, and they look fine. My compass readings look fine. I attempted to do tilt compensation because it's pretty important when you're running over rough territory. My tilt compensation is not working well, and I've run out of time to troubleshoot it. I've got to go on to some other stuff. It works kind of, but it's really noisy, which means it needs some filtering. And one of the axes doesn't seem to be going in the right direction all the time, so I don't know why. Not something I need to worry about now because the compass readings themselves are very stable, and although they're not tilt compensated, they're still probably good enough for what I need to accomplish. As I mentioned, tonight and tomorrow I'm working on latitude and longitude path following logic, which looks fairly straightforward. I have a C++ model to follow, plus I've done this before using XY coordinates and had it work quite well. I am intending to add obstacle avoidance, obstacle detection and avoidance, assuming that the path following logic goes well. I probably will not have any practical way of doing cone detection. I have no cone detection video devices or sophisticated devices, and attempting to find them as well as doing obstacle avoidance with simple distance sensors is probably not going to happen. So I will be quite happy to get within that 10-foot circle of the cones and get all the points I can get, hopefully, if that works out. What else? Any questions?
Boy, you're starting on waypoint following tomorrow.
Yeah. One trick pony.
That's late, Tom.
I still have to get back out to the park in order to get the GPS coordinates checked out to make sure I'm happy with what I'm measuring. Just as an aside, in the work I was doing on my GPS, when I got it all hooked up and running and all the functions working with it, it blew my mind that sitting here in my basement with my whole house on top of me, I got satellites, but not always. Sometimes I'd get them and sometimes I wouldn't. So I did some work to find out more about that. And I stuck the most amazing online tool in the chat at the beginning of the meeting, which you may want to have a look at if you're not familiar with it, from a company called Trimble in Germany. They put this thing into the public domain, and it allows you to identify your location and what you're interested in finding out. And it will do future predictions of satellites, their routes, their strengths, how many will appear at your location. It's the most amazing tool I've ever seen, which explained a lot as to why sometimes I get satellites in my basement and sometimes I don't. I always get satellites outside, lots of them. And that's with just a GPS receiver. It's not GNSS. So I'm not too worried about the way that's going. My latitude and longitude information looks quite stable. So I think it will work well in terms of establishing the location of the robot at each point in time and then using it to plot the forward path to the next waypoint. We'll see. We'll see.
Well, good luck. We'll be looking forward to hopefully seeing it work on Saturday. And for anyone who's going to be remote on Saturday, we will be live streaming it on the usual DPRG channel. You can hook in through the usual URL, and so we're going to start. You guys will be starting around 10 a.m. Central, I understand.
I guess we'll see.
Yeah, we'll see how things are so often different on the day.
Pat's looking after our live broadcasting, right, Pat?
Yeah, 6 p.m. Central.
We're going to go with Newfoundland time, right?
Exactly. We'll get dark.
We don't have power at the site. I was going to check. The bathrooms are supposed to be open until the end of October, so we'll see. Otherwise, it's a short trip across the street to the local cafe.
Okay.
I thought you were going to say it was a quick dash to the woods or something.
That's actually closer.
If the bushes are tall enough, that may be the spot.
I grew up in this area, and I admit I have spent a lot of time as a kid in the woods in this park, as kids will in the summertime. So yeah.
All right. Any questions for Tom? If not, I'm going to kind of follow up really with a follow-on to Pat's. Are you done, Tom?
I am. Thank you.
Okay. With a follow-up to Pat's issues, because I've been having many of the same issues. And so partly I want to show where I'm at, but partly I want to ask a stump the club kinds of questions on compasses, and because I have it's been giving me just fits. So let me just share.
Compasses are evil.
But they're a necessary evil, right, Pat? Right, Cream?
There is no need for a compass.
Gyros.
I'm staring at my data, and it's working wonderfully.
Are you guys seeing my laptop and a video with the robot in the back? Okay, so this was this evening. First time it actually drove straight, not straight enough, but you can see I've got a tripod on the back with the GPS antenna, and then there's a mini tripod on the top below, inside of the top one, with the compass on it. And it was doing this weavy driving last year, and I haven't done anything to fix that. It's basically got bang bang control. If the heading is outside the dead zone, then it applies correction in the other direction. But I've just had fits with the compass. Okay, so that's basically about probably all that's really interesting to watch at this point. So I'll stop that. And
Is that weaving side to side? Are you trying to drive straight?
yeah,
Is
but
that weaving side to side because of compass inputs
no, yeah, well,
or bad
actually,
PID or what?
I don't have PID. I just have bang bang, full left or full right, if it's outside of the dead zone. I'll show you a graph that sheds more light on that. But first, I want to, let's see, are you guys seeing this, or is this readable? This
Yep.
Spreadsheet's way too small.
Yeah, can you zoom in?
Yeah.
That's Control plus.
Maybe somebody can read it, but not me.
Controlling your mouse wheel.
Or Control Shift plus. There you go.
Uh-huh.
Okay, so I was having such a bad time with just the phone, the IMU not being consistent. It's a BNO 055, but I've not done any calibration or saved parameters or anything. So the sort of first Stump the Club question is that a really bad idea? I did calibrate my phone compass by laying it down, pointing it to north, so it read 0, putting a line on a wooden table with no metal underneath it, and assuming that was reference, then rotating it 45 degrees on a protractor, and so I got an error of 2, maximum 3 degrees on my phone compass. So I believe my phone compass is actually pretty accurate. But so I've got 3 sets of robot compass calibrations here, and I'm trying to make, so not east is 0 degrees, so it's like in math. So 90 degrees on the compass should correspond to a reading of 0 from the IMU. And I positioned the compass, I positioned it on its mount so that would be the case. And so then here's the IMU readings I got, converted them to degrees, and here's the error in degrees. This quadrant between 45 and 0, maybe beyond 0, has a maximum error of 15 degrees. That's with no calibration. So I don't know if that's like expected or like okay. But what really threw me for a loop is then I came back without changing anything, without like relocating without moving the IMU. It was still on the pedestal on the tripod, 4-legged tripod that was still taped down to the top of the robot. And at the same heading of 90 degrees, all of a sudden I'm reading 4.92, which is 282 degrees.
So I think I can tell you what's going on, Paul. I have a BNO, and I've experienced the same problem. It will auto-calibrate on startup, and it takes, depending on how much you move it around, it can take 2 or 3 minutes to auto-calibrate. And once it does, the heading will dramatically change all of a sudden.
Oh. Okay.
Yeah.
Oh boy.
The magic calibration.
So what do I need to do?
Spin your robot right after you start it up, and it'll calibrate a lot faster. It could still take 30 seconds though.
Okay, well, all of this was like well after it'd been much more than 30 seconds after it'd been powered up, because I powered it up, and then you fiddle faddle around and you rotate the robot, and then you take some readings and put them in the spreadsheet. I mean, there was a lot more than 30 seconds. This is more
Okay.
like that.
No, maybe it wasn't. I've seen it take as long as 3 minutes.
Oh, okay. So maybe that explains that one. So
Yeah.
I came in this afternoon. So this was this afternoon, and then later this afternoon, I was out on the back lawn this afternoon, and then and it had been powered on. I'd been driving it around, and I observed that it was just reading wrong. So I said, okay, I'm going to fix this. So I rotated the base of the thing by I'm not sure which, 90 degrees or something, because these are consistently off by about 70. Anyway, I rotated it so that 0 read 0, and now I've got like reasonable numbers, but I don't know if they're going to stay that way.
Well, you can control your robot under manual control.
Yeah.
So a nice straightforward calibration exercise is, for the first minute after you turn it on, drive it in figure eights for 60 seconds. And that will probably give enough of the sampling of different orientations for the calibration routine inside the compass to do a reasonably good job. In my case, there is no internal unit, but that's effectively what I do whenever I invoke the calibration procedure. I turn it on, there's a timer that runs collecting data, and I drive it in a figure eight for a minute around the grass.
Oh, really?
Yeah, and
The
I should
process-
tell you the B&O will not auto calibrate if it's not moving.
How does it know if it's if the heading's not changing?
Sure.
Yeah.
And you really do want to calibrate it at least once in a while.
Oh.
Because if you don't, how does it know?
Oh.
Yeah, and the B&O will auto calibrate every time you turn it on. So until it's calibrated, it doesn't know which direction it's heading.
Oh.
Yeah, that's the unfortunate part of automating the calibration procedure. They don't explain to you what you still have to do.
Yeah.
Oh.
It's really annoying, which is why I ended up turning off the magnetometers and putting it into the gyro and the gyro only mode for heading.
Paul, are you using RTK?
Yes.
So you don't need the compass at all. Compasses are evil. Destroy them all. Get rid of the compass mode, like disable the compass mode on the B&O.
I agree.
And calibrate your heading just by driving the robot completely straight, no inputs whatsoever, and for a good distance. And if you got an RTK fix, it doesn't take long to get your bearing from the direction of travel, from your start and end points.
Yeah.
And then you use that to do your offset on your IMU heading.
Oh, okay. Okay.
That'll give you a GPS RTK accurate heading on your IMU. And from that point on, there's still a possibility that it can drift, but it'll tend to drift pretty slowly. And you can always choose to update it on the fly, your offset on the fly as you're going.
Okay.
And then you don't have to worry about any magnetic anomalies whatsoever.
Do you have your RTK working reliably now?
Is what?
Do you have your RTK working reliably now?
Yes, I do. It was a struggle to get it there, but I found that it had to be so. I had some help to try different heights of the antenna above the robot, and we found that below about 2 feet, it wouldn't recover as quickly if you shielded the antenna with your hand, and it wouldn't come down to as low of a horizontal accuracy reading. But out in the backyard, it will go down to 1.4 centimeters of reported horizontal accuracy. Not always. Sometimes it jumps up to 2 or 3, but it's working pretty darn well. I've had some help. I've been using a package from from Aussie Robots, some guy in Queensland who built a replacement for the standard U-Blocks package that from Kumar Robotics, and the satellite part of it, satellite node, is working great, but the Intrip client was crapping out. It would die and stop providing corrections that the satellite node needed, and things would go to hell in a handbasket. And it even got me banned temporarily from RTK to go. Like
I've got a fix for that.
Oh yeah, what's that?
Yeah, I'm about to push it upstream as a pull request. But it is so with RTK to go. I don't know when they instituted this policy, but they now have a limit on the number of retries, or on the number on the rate at which you submit the RTCM requests.
Right.
And you got to keep it below 1 hertz or at 1 hertz, which kind of makes sense because they also limit the publishers to 1 hertz. So it doesn't help to actually request the data more often, but they've got more strict with this policy, and they put you in something called sandbox mode.
Yeah,
now.
I was sandboxed.
Yeah. So I've already submitted the fix to. Oh no, I haven't. I've asked if somebody wanted the PR on the GPS RTK.
Which package is this?
This is it's confusing, but there's a package. Let me look it up.
U-Blocks DGNSS?
No, I don't know that one.
Okay.
I've been using one that combines the standard Intrip client, the Kumar U-Blocks one, and then they have a separate little thing that that generates an NMEA message to send back as a separate Python script. And that one is like ready to go, but it sounds like you've already got got it all working, so you don't really need to depart from
I'm using a package called Intrip client.
That's what I'm using.
Ross Humble Intrip client.
Huh?
Ross Humble Intrip client.
That's all part of the name, or just Intrip client?
Yeah, that's the package name.
Oh, the package name. Right. Okay, yeah, that's the one that I'm using, but that's the one that will get you banned if you.
No, that's not getting me banned.
Really?
It was the one that was built into U-Blocks DGNSS. Ross Humble U-Blocks DGNSS is.
I don't know that one.
Yeah, that's the one from this guy in Australia, and he was real helpful. I filed a bug for his RTK client going away, and he was, he responded in great detail and gave lots of good information, but ultimately it still didn't work. Well, it's interesting that you've got a fix for that, but I'm not getting banned with the Ross Humble Intrip client. Okay.
Oh, that's good. What's the rate at which you're sending out? So you need to be sending it out for quite a while before they ban you. It's like for me, it was I can run it for a few hours just fine. It's when I run it overnight that I get banned if I don't have it throttled to 1 hertz.
Well, I don't know what rate it's running at, what rate it's requesting at.
The default was 10.
Oh, really?
Yeah, 10 hertz.
Ooh.
So that's and that was in that client. It was fixed at that, like it was hard coded.
Oh.
And so now I've made it a configurable parameter.
I might be interested in your fix then, because it sounds like we're using the same Ntrip client.
Yeah, it's certainly possible. Let
Okay.
me put a post a link to mine.
Yeah. And the other thing so thanks, Pat. That's real helpful. And thanks for the tips on the compass, everyone else. That's going to be great. So what are you guys seeing this plot juggler plot?
Yep.
So this is the run where that I showed the video of, and it was supposed to be heading for 25, minus 30. So it should have actually gone up a little bit, and it cruised past 25 because it was outside of the 1 meter capture circle. So, but it didn't turn back. So, like, what should I do if it? How can I detect the difference between it passing by the circle and starting off pointing the wrong way and turning around?
I thought David looked at the successive readings, and if it was getting further away, then he knew.
It does that when you're inside of the capture circle, but if you never reach the capture circle, then that logic
then it
doesn't get triggered.
Oh.
So anyway, I still have a problem of it drifting off, and I don't know if this is the compass or what, because it's steering by the compass. Then I've got a strange bug that, I mean, I've got this compass.
So you're
oh
so you were looking for a waypoint at 25,
yeah,
assuming meters or something.
yeah. 5 meters in X and 32 meters in Y.
So it didn't give you a heading like 180 degrees back to circle back after it passed it?
Well, here's the heading, and I've got something going on. I put some logic in, and I can't see the flaw in it, but every second when a GPS reading comes in, I take the reading, compute the difference between it and the odometry heading, and save it away as a correction to not heading. I'm sorry, odometry X and Y. And save it away as a correction to save the UTM. Oh, maybe it's easier to just, so here's the, let me see, driveway points, callback. No, it's in parent. Yeah, so when UTM is the satellite callback, can you go, oh, I'm not sharing this, I'm sorry. Anyway, this zigzag thing and is so strange. I'm like, I know I've got a code, I know I've got a bug in the code, but I just cannot see it. Window, here we go. Here we go. So UTM callback is what gets called when there's a satellite measurement that reports X and Y in a local coordinate frame, so it has offsets like 20 and 35 meters from my local origin. So I save the message away, but then if odometry is started, I save away a UTM to odom offset of X and Y as being the position, the satellite position in X and Y minus the odometry position in X and Y. So odometry coming off the wheels. And then when odometry comes in, which I save that message away, but then I modify it by adding to the odometry X and Y this offset. And that ziggy-zaggy bearing stuff started when I put this logic in, but for the life of me, I can't see what's wrong with it. So anyway, need to put more debug logic in, I guess, and no one else sees anything else wrong with it either. So okay. Well, I was hoping. So, that's where I'm at on Saturday. After the meeting, I head off to New Zealand for 3 weeks. So I really only have the rest of this week and then the week before the competition to get this thing like driving properly and get bumpers put on it. So it doesn't have the bumpers at the moment, but I do have my new PLA bumper assemblies, and I'm getting the local library to print off some not PLA, ABS versions of this. So hopefully they'll be stronger. And I got to do the logic to handle the bumpers and shut the motors off quick and feed that back up to the logic to tell it the move is over. And then there's the matter of the OD light for detecting where the cone is, and that may or may not happen. So anyway, that's where I'm at. We got the gold star for Pat and for me, so for showing a robot moving.
Paul, I think you wanted to thank Kareem and not myself for his input on your program there.
Yes, thank you, Kareem. I'm going to note that down as so.
Because tonight I didn't solve anyone's problems. I just created more for myself.
Yeah. Pat, I sent you the code in an email.
Thanks, Tom.
Yeah, thank you, Kareem. So get rid of the magnetometer. Just take the gyro readings, drive straight for a little bit, and get my heading off of RTK GPS, and then apply a correction to make the gyro line up with the RTK reading. That should be easy.
Yeah, for RAWs, it's a little different if you're doing proper translations through or transforms through the different coordinate frames. But you know all about that. So because what you're doing is you're aligning to so there's another package called robot localization, which I don't think you're using.
Correct.
Yet. But it will sort of take care of all of that for you. Because if you do this, then you just need to make sure that like if you align it according to the direction that you have traveled, that will put your IMU in sort of Earth coordinate direction, which might be different from your startup because when you first get going, your IMU is going to be robot oriented heading, right?
Yeah.
So you're putting your robot into Earth or world sort of coordinates heading by doing that. So they're just got to watch out for that because in a non-RAWs robot, that's usually the way I want to do it. Yeah.
I'm afraid I'm in the interests of time. I'm not using TF and not doing all those transforms and broadcasters and such.
Well, then this should work for you just fine.
Yeah. Great. Thank you, Kareem. Okay, next up was Ray.
Okay. Well, it's let's see, what would you say? A story of finding the next shiny thing, you know, as far as robot development. I guess my current platform is differential steering, and I've used it before in 2 other contests, but it had some, I guess, things that I didn't like about it. And one is that the caster wheel on the back is kind of small. It's only a 3-inch caster, and it tends to catch on grass clumps and, you know, Texas soil holes and cracks and that kind of stuff. It just falls in, and then it's like a spud or an anchor. It just, you know, it can't pull its wheel out of the hole. So I decided to look at 4-wheel drive platforms and made this one. So this one is, they were motors from Surplus Center to 2 DC motors. I don't know if you can see them here and here.
Yeah.
I
Man, that's a
machined
monster
brackets.
robot.
What's that?
That's a monster robot, right?
It's pretty good size. Yeah, it
Right,
weighs a lot
totally.
too. Anyway, so I machined brackets for bearings that had, you know, that was working with 1/2-inch shafts. And you know, these are 12-volt motors, and I was running it on a 4S battery, and it works pretty good, but it is very heavy. It probably weighs, if I had to guess, maybe somewhere between 15 and 17 pounds or so.
Wow.
Anyway, so
That might
then I
give- that might
got
give
into, started looking at 3-phase brushless motors, and made this frame, which has got the two motors, and that's a pretty good size plumbing fitting to raise the tail end up so I could put a bigger caster on the back of it. And didn't really have, and oh, this is the bigger caster. This is a 6-inch caster versus the 3-inch one that I had on the other one. So I thought, you know, that may get me across some of the serious cracks in the earth over at Steve's place. Then I looked at Go Builda. So this is a Go Builda platform based on the same wheels, and it's much lighter. The aluminum frame and a lot of the, you know, just the frame itself is a lot lighter than that heavy sheet of plastic was. Oh, and that was kind of a neat thing. I looked at polycarbonate sheet. I couldn't believe that the cost of polycarbonate sheet these days. An 8x10 piece was like $23 or $24. And we like to walk around in IKEA because it's, you know, it's air conditioned. And anyway, they have these little trays for, I think it's less than $2, $1.50 or something like that. Anyway, they're fairly thick trays and much bigger than, you know, 8x10, and a lot cheaper. So that's what I cut the edge of the tray off basically and screwed it to the bottom of the thing. So again, the other one is made out of 1/2-inch thick plastic, and this one's, you know, the electronics sit on something that's maybe 1/8 of an inch thick, so a whole lot lighter. But yeah, this is the, like, from Lowe's Lexan sheet that I was amazed at how expensive it is. I know Lexan.
How much? You
I
paid
thought
for
it was-
that, Dan?
like $25 or something.
Golly.
Yeah, you can
know,
look it up, but that's
Place over in Grand Prairie that sells a whole 4x8 sheet of Lexan, like you got there.
yeah.
Pretty reasonable. It's a plastic warehouse where they sell sheets of plastic, and it's way cheaper than that. Over in
Yeah,
Grand-
I was surprised. I don't think I paid that for this. So I don't know, maybe the price was wrong, but I was like shocked that it was that high.
For
Anyway,
how big?
so
That
I've
was
got this
How big?
platform. Well, right now I have the Abino 055 on it, and the Neo, I think M8P-2 for a GNSS receiver. I was a little disappointed about these batteries. I got another one that's getting fat again. So this was a 4S, and you can see this is the where it's bulging out on this one cell, and the one cell's like completely dead. Reads 0 volts. I thought ZOP, ZOP Power was a pretty good brand. I don't know if other people have experienced that, but this is the second one that's done that one cell just like completely dies. And so I was a little disappointed by it. It's kind of like, darn. Hopefully it's not something I'm doing to the batteries that are making them die. Anyway, so the latest 4-wheel drive platform works very well. It doesn't get caught on grass. It has a very low center of gravity. So it can't, that was the other thing, the differential drive one would tilt forward, and then it would hit its bumper switch. And so it would like tilt forward, engage the switch, and then it goes into an avoidance routine where it would, shift over to the left or to the right, depending on whether the left switch or the right switch was hit. And that it takes a lot more time. So, if I can avoid those issues, and it's got much better traction. The other one, if you got caught on a clump of grass, the wheels would just spin. The motors were powerful enough, but it just wouldn't get enough traction with 2-wheel drive. So hopefully those are all things that are going to make for a much better platform. It's lighter. Those are actually 24 volt motors, but I'm running them at, the nominal 14.8 volts, just based on one battery. But now that I have essentially a 3S here that was a 4S, maybe I could stick them together and not go over the, whatever it is, 34 volts, the RoboClaws, they have a limit of what the input voltage from the battery can be. So I still would like to get back to kind of experimenting with the hoverboard 3-phase motors. I took them apart and looked inside. I wanted to try to get one of the small magnets, and these, it's got like I think 8,192 count per revolution encoder on it, but there's really no room on the inside of the thing to to put the magnet and the sensor. It's very tight. I thought about putting it outside, but then it's probably going to get caught in grass and weeds and stuff. So, but I do have some smaller DC motors that I want to play with for the indoor contest, and those actually, 3-phase brushless motors with optical encoders on the back. So those I think will be much easier to use. The one brushless motor driver that I was using is very sensitive to setting up the wrong parameters. You do one thing wrong, and you're most likely to fry the thing. And they kind of warn you. They say, instability can harm device, and instability is very easy to do with one wrong setting or one setting that's just slightly out. So I was a little disappointed in that, but I'm looking at some other drivers now, that like I think it's the I'm not certain, 62. No, I forgot what the part number is. Anyway, it's a fully integrated driver. It's made by ST. It's been out for a while. And I think it has just more of the protections that you need for experimenting with, three-phase brushless motors. And the discrete MOSFET solutions are good, but if you get shoot through, it shorts out the 12 volts that the upper MOSFET needs, and then it just pops the device and
through bad.
Yeah. So I don't know. So the discrete ones do, I think they're cheaper to manufacture. You couldn't get the drivers, I think, during COVID. Nobody had them. So everybody went to a discrete solution, but when they did that, it's like I think they actually needed to add multiple or isolated high side voltage generators for each of the MOSFETs for 2 motors. So, which is like 6 drivers. Anyway, so the Go Builder platform's much better. It's much lighter. Seems to, get through the grass easier. I actually have an inch more ground clearance. So I'm kind of hopeful. So, I got an RTK setup working. I'm going to try to incorporate that. I did kind of experiment with the MaxSense camera and got, models working, but I don't know if there's going to be enough time to integrate that as well. I may just go back to the OpenMV H7 and do blob detection. And that seemed to work pretty good. So anyway.
Are you referring to for Robo Columbus this year, Ray?
Yeah.
So you're going to come and compete? That's great. I thought you weren't going to compete this year.
Oh no. Mike Williamson said he wasn't going to, but I want to.
So. Excellent.
Anyway, so hopefully everything lines up and
Wow.
Yeah. So yeah, one of the things, I mean, even stupid things like, I've got 3 quarter-20 bolts and nuts that bolt the wheel to the hub. Well, just from, walking, kind of going around, let's see, what would it be? The right side wheels actually will back the nuts off the bolts. So I've got to get lock nuts on everything so that, that doesn't happen. But yeah, it'll be going along and I'll hear it, it'll just start dropping the nuts on the right side. It's like, cut that out,
back in the day, I think Plymouth, my brother had a Plymouth Valiant that on one side had left-handed threads.
Right. Yeah. Left-handed.
Nuts.
Yep.
Yeah. So that's funny.
Yeah. So yeah. And lock nuts aren't that expensive and they work pretty good. So
hey Ray, you could also do something like a castle nut, or drill the nut and put a garter pin through it.
Oh God, yeah. Hopefully lock nuts will work good enough.
Okay.
Some removable Loctite glue stuff.
Yeah.
Yeah, that's another one.
Yep. Yeah. But yeah, I couldn't believe that. It's like, God, I just tightened those up a few minutes ago, and it's like, they're all loose again. So maybe it's the Plymouth had the same issue. They just went to left-handed threads or something. I don't know. Wheels kept falling off the Plymouths or something. But anyway.
There's going to be some stiff competition at Robo Columbus on November 23rd. If you've got RTK and Max Sense, and I know Doug's got Max Sense, and Scott always has a really strong entry. I'm
Yeah.
kind of shaking in my boots right here.
Oh, you'll probably do fine. Oh yeah, this is actually the Max Cam, not Max Sense, but I called it the wrong thing. So
Wow.
I'm using
anyway, so that's all I had.
Thanks, Ray. That's pretty neat. So you showed us two very large robots. Like, how come you got lots of large robots laying around?
It's I don't know, like I said, it's like, chasing after the next shiny thing. I thought, okay, I really liked, the idea of going with four-wheel drive. So I thought, okay, I'm going to machine my own parts for this thing, and did it. And it worked okay, but it's just very heavy. And those motors draw about like 4.5 amps each, and, under load. And that's quite a bit in comparison to the Go Builder motors, which are, I don't know, maybe probably around half that. So, and just, steel chain. I used keyed shaft, so I actually welded. I got the cheapest sprocket I could find for a 1/2-inch shaft, because it had a key cut in the center of it. I didn't have any method of cutting keys. Anyway, so that's how I attached the hubs to the shafts, and they're all steel.
Is the Go Builder robot the one you're going to compete at Robo Columbus?
Yes. Yeah.
Cool.
So, but it's, everything's aluminum on it, or not everything, almost everything on it is aluminum. So it's, if I had to guess, maybe 12 pounds, a whole lot easier to carry than 17 pounds. So,
so are you going to bring it on Saturday to the meeting for us to have a look at, a gawk at?
Yeah, sure, I could. And I'm still using ESP now, and the little strap-on thing with a battery, so that I don't have to get down and try to stare at a little LCD screen to see if everything's working right or calibrating. Oh, on the B&O 055, I actually checked the calibration routine. The B&O can respond, I think, up to like 100 hertz with different, inquiries of things. So, like when I start off, there was a video that said, you could kind of rotate it in yaw, and I forget which way pitches front to back. But you could do the 3 rotations in the 3 planes, and you could actually see there's like a total system calibration. There's calibration for the magnetometer, the accelerometer, and the gyro, and it'll go up to 3, starting at 0, if you get each of those calibrated. And that's what I was doing last time. Of course, every time I started up, you got to go through this routine, because it doesn't keep the, any of the calibration information. But that seemed to work pretty good.
I think have I read somewhere that you can actually read the calibration data out of it and save it away on disk and then store it back in?
That can
I think
be
you
done.
can, yeah.
Yeah, you can do that. And there's a guy on Adafruit forums.
Right.
He's done a lot of stuff with the B&O 055, and he's tried to get around the auto calibration. The problem with the B&O 05 is that you can load the values, but as soon as it starts up and goes a bit, it totally it doesn't auto calibrate, and whatever you had in before just goes out the window. And I want to say there's more to it than this, but there was something that he was saying. What he does is he stores his calibration values, and then when it recalibrates it, he essentially reloads his calibration. Okay. So there's more, like I say, he's got articles on it, and I think he's even got a YouTube video. I threw in a few links that are part of it, but I don't know if I got it all. I have read about it, but he seems to he seems to indicate that he is very comfortable with overcoming the issues with the BN055. But most people, you know, who like at SparkFun and other places that I saw run, they just ran it in the IMU mode, which is just gyro and accelerometer, or they ran it in the gyro only mode. And they claimed it did pretty well. There's an interesting mode, which I think it is M4G, which essentially is accelerometers and magnetometer. So there's two advantages to that, assuming you trust the magnetometer. One is that you get a slightly lower power, but the other thing is you don't get any drift. You don't get gyro drift. Okay, so that's real intriguing, but I don't have enough time to screw with it. I'm just saying it's interesting that that's there. So if we felt very comfortable that we had the magnetometer nailed down, then the M4G mode might actually be something. It's a fusion mode, and it uses the accelerometers and the magnetometers. Anyway, something to think about.
Thanks, Doug.
Anyway, that's all I had.
Wow, cool. Let's see, Michael, you're up next.
Yeah, it's going to change gears a little bit here. I've been out for a while. I worked for a year. I went back to work part-time. It's kind of why I fell out of the forum here. Too tired to mess with stuff. But anyway, I'm not doing it anymore. I'm back fully retired again. Anyway, I had a claw machine last year, something I was showing y'all. Maybe y'all remember, maybe you don't. But anyway,
Mike, I remember it.
It worked on an arm with gear. It never worked out. I couldn't get my engineering was way off. So anyway, I'm going a different direction. I'm making a new claw machine. It's right here behind me. And I know it's a little different than a robot, but it's still in a lot of concept. It's going to have a boom up here. And this table is going to rotate, and it's going to have some Lexan walls around it. I can turn it on against the rotate here. See how that turns?
Yep.
Then I'm going to have the claw, which is this right here. With claw will be hanging down here, and it'll just go in and out. And y'all see that? I guess.
Yeah.
Yeah, and then I'll have the ability to, have a joystick and the ability to stop the table from turning and then just drop the claw. I thought that's a neat concept. I'm kind of proud of something. I didn't have anybody to brag about it to, so I'm gonna.
That's why we're here.
I'm going to show you this. I got a little machine shop back there, kind of like you, Ray. But these are going to be this is square tubing, and I 3D printed these guys, and I want to show you this. I designed with FreeCAD my own timing belt. I think it's a GT2, the same thing they use on 3D printers. And but I'm real proud of it because I drew the thing myself. I didn't copy it off of Thingiverse. But I don't know. Y'all see that? Pretty good.
Yep.
I made this timing gear and then the small timing gear right here. But what I'm real proud of is this timing belt I made. And I don't know if that's sharp enough to see.
Yeah, I can see it.
But the it works. And it hadn't broke yet, so I kind of proud of that. And
Hey, Michael, what's it made out of? TPU?
you. Now, I don't know how long it's going to last, but the thing about this stuff is I can make it as thick as I want, you know,
Yeah.
because I designed it. I can make, so yeah, TPU. And I've got a big 3D printer back there to print it on. So that turned out really good. I was real happy about it. So
Okay, so when you printed it, did you like kind of like coil it up or something so that you could fit on there?
it just laid on the bed like this.
Damn, that's a big bed.
That's a big bed. It's 11 inches square. So, but I've seen a guy on YouTube where he drew his like this, but
Okay.
I didn't have to do that. I just did this. But anyway, it's working. I'm real happy.
That sounds great.
That's cool.
And,
So did you add any reinforcing to that somehow? Or is
There's
it just,
reinforcing. That's why I don't know. But the thing about it is, if it doesn't hold up, I can buy a closed loop timing belt on Amazon if I
oh
have
yeah,
to.
yeah.
So, but
Certain
it's all
stuff.
to the teeth are to the specs, and I've bragged about this before, and about FreeCAD, and I'm real happy with where FreeCAD's going. It's giving you the ability to do stuff like this. So, as far as the gears go, here's my gear. Pull it up, show it to you. There's the gear. See that? Yep,
Nice.
pretty good.
Big gear.
So, I don't know. That'll probably be ready next year for next Halloween, the Halloween carnival at my church next year. So, anyway, I got another little thing I'm trying. I got another project I'm building. I'm building these. I'm going to build this just concept but these are 3D printed speakers cabinets. I'm going to make some little Bluetooth portable speakers for my grandkids and kids this year for Christmas with like their name on them or something, you know. And I've got several different off of where was it? Don't know this place. AliExpress. I
Yeah.
bought several different Bluetooth interfaces that I'm gonna add to those little speaker cabinets, and I got all kinds of. I went crazy and bought all kinds of different ones. But you know, it's like $3 a piece. What difference does it make, right?
Yeah.
So anyway, that's where I'm going with that. I just wanted to show you. I know it's not really robot, but it is. It is DC electronics, right? So.
Yeah, it's good, Mike.
Yep.
But anyway, that's all right. I just wanted to show that off. When I make the progress with those Bluetooth speakers, if it works out, I'll show that off later.
Yeah, I got to admit, the belt is kind of intriguing because
Belt?
yeah, because you know sometimes you just need a belt, and you don't really, you know, if you could print one out real quick, that would be really nice.
Yeah. So the thing with this belt is, like you said, is all I got to do is I can go small as I want now because I know I can make a big one. So, and anyway, I had to draw them. I just drew one rib in there, one tooth, and then just multiplied it around the drawing.
Yeah.
So it works pretty good.
I
That's
like
all I got.
like the spinning turntable.
Yeah,
I
I
do
actually tried. printing
You
some
got a
GT2
question for
cards.
what you guys that y'all was talking about Jason coding here earlier. Well, how is that different than like does it have electrical code in it? Libraries like you would Arduino?
No, it's more of a data. It's like a data. It's like a configuration file. It's just a way of configuring data in a specific format.
Do you know what an XML file is like or is?
Oh, I thought he was interested more about JSON files.
Well,
Yeah.
yeah, it's the same thing, but
Oh,
a JSON file is the same thing as an XML file. It's nothing to do with electronics or circuits
Yeah.
or anything.
That was kind of my question because I had seen it, but I don't know anything. I'm not a programmer. I'm just a piddler. So I just piddle with stuff.
Yeah.
All right. Well, thanks a lot.
Cool. Thanks, Mike.
Yeah.
Let's see, Harold. Where's Harold? Harold disappeared. I had lunch with Harold today,
Oh, cool.
but and he had something that he wanted to share, and I don't remember what it was. So maybe
Was the thing that he put out on Discord?
the 3D printed kids gifts. So I printed him off. That's why we got together for lunch, so I could give him 18 little pink cars, and I guess he'd probably still like it if anyone else wanted to print it off. It was a 33 hour print job to print 9 of those cars on the bed. But hey, it was all right. I just put the printer in the spare room and said to work, and came back a day and a half later, and there they were.
wow.
That little printer I got from you, Doug, is working great.
Well, that's what it was for. Yep.
Maybe if we all yell, we can get his attention. Harold, Harold.
Well, who's next after Harold?
There wasn't anyone after
There he
Harold,
is.
so
Here it
does
is.
anyone else have anything?
Okay, I
my name
got
3
something I
times,
wanna-
like, people
I
just-
got something I want to show people who might. It just came out from Wave Share.
I'm helping the wife, guys. I'll be in and out. So
Okay.
wait.
Yeah. It's our screen. Okay. This is from WaveShare. Just came out. It's a new. It looks like it's very equivalent to the Garmin. What do they call it? LiDAR Lite.
Mhm.
The Garmin LiDAR Lite type thing. It's got some pretty amazing specs.
Wow, 50 meters, huh?
50, yeah, for $30 you get the 50 meters. Let's see here. You can see here if you watch through this, it has a real short, it's only 5 centimeter minimum range. So that's really nice. It is a laser, I believe. The field of view is 1 to 2 degrees, so it's pretty narrow. It has, this is a little confusing. They actually have three communications. They have a UART with 3.3 TTL, so it can work with 3.3 volt microcontrollers. It's got I2C cascading support, so you can have up to 8, I believe. And then it has a general purpose IO type thing. Very high. You can increase the baud rate much higher than what you have, which is pretty good because I believe I was going to see if I can find it. It's got an incredible refresh rate. I want to say it was 100 hertz, but I'm not without seeing the spec. I'm not sure. We can do this. See if it'll take me to it. See, where is it? Down to here. Where is it? They have instructions for all of the GPIO and and stuff. Let's see here. D.
Does it come with a connector?
It has a connector on it. I don't know if it has a cable.
Oh,
Let's see if it says here.
Search the page.
Oh,
for
here,
hertz.
look at this. Approximately 100K lux, illumination. So that's pretty dang good. That's bright outdoors. Why do they not show the? Why aren't they showing the rate?
Search for hertz.
Yeah, that's a good thing. No, it's not on that page, so let's go back.
Just HZ.
HC.
Oh. No.
Nope.
Yeah, let me try here.
So,
No,
Doug, where would you use a single point range sensor like this in a robot?
on a
well,
servo.
Stick it on a servo. Yeah.
yeah, you stick it on a servo. If you're getting, like I say, I wish I could find it because I did see it. It's got a very, like I say, a high
Rate.
rate.
Refresh rate, 100
Oh,
hertz.
there
There
it
you go.
is, 100 hertz. Okay. It must be in the picture, so it's not HZ.
Hmm.
Okay, so 100 hertz, you could ping along. And if you're using another thing, you could do it in a case of a cone detection. It would definitely allow you to zoom to check your. Otherwise, when you says your cone is centered on your robot, you could also kind of get a good feel for how far it was.
Yeah.
There definitely would be in its range.
Okay.
I mean, I think a lot of these probably don't get used on robots, but drones is an obvious one.
Yeah.
And then things like this
Right.
is an obvious application. But my thought is I think it could be used for obstacle avoidance. I mean, that's why I looked at it. And when you look at the specs and everything, the only thing that's different between these two is one costs $20 and one costs $30. Or one costs 21, I think. Let me see here. 23. So I'm not even sure why you would get a 25 meter one when you could get a 50 one for like $5 more. It's because there's no, like I said, there doesn't seem to be any spec differences. Anyway, I thought this might be something that people would be interested in because I know a lot of us had LiDAR lights back in the day.
Yep.
And they were always a little tricky. This one might be a little tricky too, but then hope springs eternal. So
You can still get them, right? The LiDAR lights or something
yeah, it's
equivalent.
Garmin, but it's a lot more than $30.
Yeah, like 150 now.
I don't know, but it's expensive because it's a Garmin product.
Yeah.
But anyway, I saw this and I said that people might be interested in it. So I'll put the link in the, let's see if I can go back. Yeah, I'll go to, I think this is the front page. So I'll grab this and put it in the chat. And I'll stop sharing.
Cool. Thanks, Doug. Does anyone else have anything specific? Or otherwise, we can throw it open for open mic.
Well, I think didn't Harold come back?
He did, but then he seemed like he went away again. Hey, Harold, are you around?
Can give an update on my
Yeah.
my compass.
Yeah.
So share my screen. So you guys can see that.
Yep.
Here we go.
Wait a minute.
A little better.
Yeah.
Yeah.
Okay. So this guy here. Why is he stuck?
Well, things look much better.
Are the motors turning?
No. So I am in the top left window. So I'm just about on target. And you can see that I'm 4,655 centimeters away from target.
Yeah.
In the top right window is my GPS coordinates. And
Okay.
so to show you, they are updating.
Rock solid.
So I'm getting GPS coordinates. In the bottom right window is my compass. So as I rotate away from my target, you can see my compass is switching. As I rotate back, my compass is moving.
Yep. Looks good.
Looks stable.
So my compass, my target is being controlled by my navigation routine. And I did find a bug in it today. So as I rotate past 0 degrees, so if you notice my compass below 360 and I go to 0, I end up with this mess. But just as I'm crossing my 0, so I'm going to have to fix that. Being able to roll in a straight line, I think, is more important right now than that.
Who was it who suggested the zero crossing kind of issue? That person
That was
gets
It
a
was Tom had mentioned the 0 crossing.
Yep.
And I looked through Tom's code to see how he does it.
The key, Pat, is to use vectors. So you add up, you average the degrees like you'd average a vector.
Okay.
Also,
So-
I haven't done it in a while, but I remember there was a key, at least the way I did it, in using radians and not degrees, and then deliberately actually having the radians scaled so that you never sort of between 0 and 360, always in some other range.
Yeah, okay.
You don't get a zero crossing, and then in the end you kind of normalize again, right, to the 0 to 360 range.
Yeah, so what I'm thinking of doing is to possibly change my compass, but even then, my compass being 0 to 180 and -1 to minus 179 or whatever, or 180.
You'll still have
But that'll still give me a problem.
you'll still have the same problem. I think you'll just be at 180 instead of 0.
Yeah, so I've got to figure out a way to just cross it over when I'm crossing over the north point.
So, Pat, can you run your motors in this configuration? I thought that was what you're going away to do.
Yeah, so I can run my motors in this configuration. So there is my target. So, and there's the problem I'm getting is, and I'm working through that one too.
Yeah, the compass is drifting.
Oh, I'm gonna lag in it.
Was it drifting or is it wobbling? It seemed
No,
to be
I've got a lag.
sitting.
Are the motors running or not?
No, my motors are not running. So if I turn my motors on, and I get my remote, and I fire up my motors,
And the GPS has changed a little bit.
Yeah, the GPS, I don't think changed that much, but my compass is, if I try it again,
Yeah,
Ooh,
wow.
wow.
Yeah.
I go back, if I can get back that far. So I'm all over the place.
There you go. 200 something.
Yeah.
You know if you've got EMI suppression on your motor terminals?
I don't believe I do.
Oh,
and
add that right away.
It's a heck of a job to pull those 4 motors out and put suppression on them.
Well, that's where your problem is, I'll bet.
Yeah.
If I can do that at a terminal block instead of on the motors, it would be much easier.
Yeah, you want to get it right on the motor terminals if you can, because you don't want any of the motor wiring to radiate the EMF.
Yeah. So if we're looking at what, 0.1 microfarads across there in the 3 capacitor configuration.
0.1 across and then 0.1 to ground, the frame ground on the motor.
On both sides.
Both
And
sides.
a good high-speed ceramic one.
Yeah. So you need three caps on each motor.
Okay. If you understand where I live, a good high-speed ceramic one is out of the question.
Any ceramic will be better than nothing.
Is in the question.
Yeah.
Well, as opposed to like a tantalum, that won't do you any good.
Yeah, no, I've ended up buying a kit of ceramic ones just for this issue for noise suppression and stuff. So I will scramble a couple hours tomorrow morning and take apart some motors. They were fun because I had to modify them to fit motors with encoders on the back.
Pat, you mean you didn't design it for maintainability?
Exactly.
Wasn't that your career?
It's not NASCAR. So that's where I'm at anyway. So there's a lot of noise when you go into this. And my GPS was fairly stable all the way through. It switches by a couple of meters, but
Well, we've solved the group has solved 2 substantial problems tonight.
so there you can see as well, if you're looking at my target values, they're switching a little bit all over the place there. They're stable. And then in comes the noise suppression. But you can see that my distance, which comes from my GPS coordinates, is maintained. So my GPS, I believe, is still working, but I think the capacitors is going to be the easiest one. Just try to solder a bunch of 0.1 microfarad capacitors on there and see where I go. So terminal to terminal and terminal to case, terminal to case. Can I use, does it have to be soldered? Because it's a friction fit on the plastic case with the motor. Can I use a piece of braid, like solder braid?
Yeah,
Yeah,
as
if you
long
can get
as
it
you
to
have
stick.
low resistance. Yeah.
Yeah, like a copper solder braid, you know, like desolder braid.
Mm.
Mm-hmm.
I may be able to get that to a better surface than soldering.
But you want essentially you want it as close to the terminals as possible and as less extra wire as, try to minimize the wire. But once you get close, being close is probably more than worrying about the leads of the capacitors themselves. Okay.
Small loop area.
Yeah.
Yeah.
So right on the motor terminals basically is what you're.
Yep.
Yeah. Okay.
Like if you look at, sometimes if you look at, I'm not sure if Polo does it, but I've seen it before where they have the circuit board that's got two magnetic sensors on them. Well, if you look at them close, a lot of times they'll have those capacitors already right there.
2 of the motors are Polulu.
Huh?
2 of the motors are Polulu motors.
Okay.
So they're 75-to-1 gear motors with the encoders built on the back.
Yeah.
The other 2 are 75-to-1 that came with the robot.
Hmm.
So they
Well,
were the same
yeah.
speed values, but I don't think they have the capacitors on them. So I'll
Mhm.
take them all apart and take a look.
Yeah, but don't forget the other guys talking about, it could be affecting your power lines and stuff. So, if you can route your digital power away from your motors and stuff like that, that's probably helpful also.
Well,
Okay.
it is. So my digital power, I have the metal frame, the two plates out of metal. So I got a battery compartment in here,
Yeah.
and I've got a metal plate at the top, or right at the bottom here, and I have my power supply is there. On the other side, the 12 volts comes from the fuse block, and all the motor wiring is down below.
Yeah. Now I'm going to have to ask somebody else for an opinion on this, but that metal plate you're talking about?
Yep.
Is it, if you take an ohm meter and go to ground with it, is it short? If you go to take,
I don't know.
go to your negative of your battery or someplace that's like that, ground, and then go to that plate and see if it's 0 ohms.
Let's see what we got.
So you're just trying to find out if the frame is grounded?
Yeah. I'm just saying is if it is grounded between his motor and his chips, it should help.
Yeah.
Yeah. What's that mean?
Yeah. No, it is not, because I got 380 ohms.
Oh, you need a ground strap.
Yeah, you might want to put a ground strap on that one, Pat. That might help too. In fact, the capacitors are always a good idea. Okay.
Yeah.
And but that other might act as a kind of like a ground plane above your, or more
Might
like,
act as an antenna.
yeah.
Oh, I'll see what I can do tomorrow.
Okay.
Well, that's it for me. I'm going to stop sharing. Thank you very much, everybody, for a bunch of good hints and tips and things to try.
Yeah.
And for me too.
Mm.
Got some good help tonight.
Yeah.
Anything towards making a robot roll forward should be good. I wouldn't have thought I got that much interference with the compass, but I can understand 5-10 degrees, but 180 degrees seems a little excessive.
Yeah. Yeah. I've never been real successful with compasses, but I'm going to try again this year because I got a compass that I have some faith in, and I want to see if it'll truly work. So we'll see how it goes. Maybe
I would have
Kareem, compasses are evil. Just get rid of them.
Yeah, I know.
You're setting yourself up for a Lucy moment.
Yeah, I know. But hey, like I say, you just always hope, Surely,
Just like Charlie Brown.
I mean, they sell so many of these things. They got to work somewhere.
Well, they work in our phones. I mean, in watches too, right?
I can sit inside my car and use my phone, and it tells me exactly where I'm going.
Yeah.
Consistently. Yeah.
Yeah.
So what are they doing that we're not?
And that's where I wondered, my truck. Well, it'll tell me that I'm heading west or southwest or, south. And it does it very reliably.
Yeah.
Yeah, but there you got to remember they're only trying to hit 16 points. They're giving you a compass.
16 points.
Huh?
I would be thrilled with 16 points.
Yeah. Well.
And these
Yeah.
get a lot better. These get down to the nearest degree. I mean, they put numbers
Yeah.
out.
I'm somewhere in here.
Yeah.
So maybe I should just put a slow PID loop on it, very slow. And just take all the noise out of it.
Something to be said for that. I mean, as opposed, well, yeah, very slow, because 2 samples at 20 hertz is not slow with the kind of varying that you're showing.
Yeah.
Hey, Harold,
Especially like if you use the gyroscope to maintain straight, whatever that means, and then so if your heading loop changes very slowly, the gyros for the steering keep it on whatever heading you pick. So that's I found success with that. Let the heading be very slow, but the gyro is nice and fast to keep the steering error low.
Yeah. So what happens with the gyro when you turn? You know, I'm heading in a straight line, and all of a sudden, okay, I'm going to turn 30 degrees. Now I'm going to go in a straight line. Does it give me my feedback from the straight line, or does it give me my feedback before I turn? You know what I mean? I'm in a curve.
PID should do it as you go. Yeah. But there's, again, there's a couple of ways you can get around that if you don't feel comfortable with it. Again, I use this when I was starting out quite a bit, is that if your angle that you want to turn is more than 10 degrees, okay?
Yep.
Drop out of the PID and just apply, drop your forward momentum, drop your forward speed, and then just rotate. Okay. That's,
yep.
If you look at like at four squares where you see a robot turn 90 degrees in the same spot, they're doing something like that. Because if you do it with a PID, what you'll see is you'll see it kind of go out and it'll kind of like come into it. It'll overshoot a little bit and come back. But if it just stops and then turns, they've stopped their forward momentum and then they're just rotating to get their whatever their target degree is.
Yeah. And it's a little harder to do on uneven grass or whatever. But what I'm doing is similar. If my angle is more than 20 degrees right now,
yeah,
I spin.
Yeah.
So stop forward momentum and spin. If my angle is less than 20 degrees, then I will drive forward and basically slow down one wheel and speed up the other.
Yeah. Well,
So
you can slow down one wheel and speed up the other, and that'll give you a sharper turn.
Yeah.
Yeah. But yeah. Anyway, sounds like you guys are both of you are very close, but you're running out of time, Pat.
I am. I've got till worst case scenario, Friday noon, I gotta leave.
Yeah, yeah.
To head south. So
yeah. So
all
right. Well, you're running on Saturday, so you're coming to be back, right?
What's that?
You're being back on Saturday, right?
Well, no, I'm heading there. So I'm gonna. I don't know if we're gonna go out for supper or whatever after.
Mm-hmm.
Yeah, probably.
So we'll go out somewhere for supper, and then after supper, I'll just crash again at the hotel. I've been staying at the Comfort Inn everywhere, so I got Comfort Inn points.
Yeah, yeah.
That's what I've been using, and I'll just crash and then get up bright and early, hit the road Saturday morning or Sunday morning, and then back to work reality that week.
Yeah.
I've got a honey-do list, and I've got my part-time work that I've got to get done.
Well, you'll feel so good when this is over.
Oh, I'm looking forward to not roboting.
Yeah, yeah. Yeah.
Hey, Harold, you had something that you were talking about sharing tonight. I think I forgot what it was.
I had a wonderful lunch with Paul today, by the way. That was fantastic. He got me some toys on his 3D printer that he got from from Doug. He now printed a bunch of toys, made his desk look like a parking lot, which is lots of fun. And good lunch today, by the way. And what I was talking about is my tack attack, and I am no way, shape, or form prepared to show everything that is. But let me explain what the problem is. I have a LiPo battery.
That's what it was.
I was trying to use these, $1.50, if that, TP4056 base chip breakout boards. Big Clive had a little thing showing them off, and I think it's Big Clive.
Mm-hmm.
One of the YouTubers like Big Clive anyway. If it wasn't Big Clive, he says he keeps a bucket of them around because he finds them so useful. And what they are, you plug a USB in one side, you plug a battery in the other side, and you got an out going on it. And it's supposed to be able to provide voltage either from the USB or the battery, whichever one has the voltage on it. And when you plug in the USB, it's supposed to charge the battery. And I think part of that is working. But what happens is this variety of chip that I have, this variety breakout board, has an extra chip on it that serves as safety. It measures the battery voltage so it doesn't get too low. And then it basically cuts the voltage to nothing, 0.5, 0.7 volts, something like that, to keep the LiPo from being sucked down too low. What's happening is I'm doing something to irritate that, because I've got this. Let me go through the things I've found out. These things are normally used on the 18650 batteries. I've got some of those slim LiPos that I understand sometimes has a little different operating characteristics than those 18650s. And I think mine even has a little bit of a circuit board on it. At least at a quick glance, it looks like it's got some green stuff off in there. So I hadn't picked back that PI tape too much. And so they are treated slightly different. I can measure 3.9 volts on the battery. I can measure 2.87 volts with the voltage out of the board. That is right until I turn on the switch. I made a mistake, Doug. I'm about to make a third revision of this board, man. You're right. Just saying. Because on my board, I got one of those OLED displays, and it seems to want every bit of 5 volts when to get it to light up and act correctly.
Okay.
So what I got to add to it is a place to put a boost, and I found a really nice boost breakout board that takes anything from 0.9 volts up to 5 volts and puts out up to 300 milliamps, and I'm only needing 50 or 60. So I found a real nice solution there. It's nice and small, and I even know where I'm going to put it on the board, right? So, but what happens is as soon as I turn that on, there's either some current draw or something that happens that makes that protect circuit kick in every time. It stays that way until I plug in the USB to reset everything, and then all the appropriate lights show up. So what happens? Here's what I'm looking for. I could give a flip about this one breakout board. It's, like I say, it's based on a TP4096, and there's a bunch of them out there. I just happened to find it. You buy them in 10 packs. That's how they sell us. It's like $8 for 10 of them, right?
Mm-hmm.
I don't care so much about the board. I've got to I probably got to redo my model anyway to make all this other stuff fit the way I've learned a lot. I thought this was going to be my final model. I was wrong about that too. But I've learned a bunch of stuff to set all that up, and what I need to do on that. What I need is a solution where I can charge my LiPo from a USB, and hopefully it's just a breakout board and it's easy to get a hold of. And I was hoping some of you folks may know I'm powering an OLED, a 0.96 OLED, an infrared transmitter receiver, and an Arduino Nano. So I measured it with my meter. I didn't measure the startup instance on it because my meter's one of those digital meters that's not that fast. I didn't put an scope on it. So I'm running after it starts up about 50 milliamps, and I'm able. I'll tell you this too. I'm able using that boost. If I hook the battery directly to the boost converter, that's only good for 300 milliamps. Oh, it works exactly like it's supposed to work and works really well. So I know even the startup current that's on there is not over 300 milliamps, or things would have gone horribly south. So that's kind of, if anybody's got ideas of how I can power it, get it into a case, something like this, and then because this is where it would sit. So where it would sit, and I get to redo all of that. I figure it's not a big deal. It's in Fusion. I can wipe it out. I can be better. I'm good with that. If anybody has ideas of doing that, I'm open to them.
I take it your problem didn't start until you added the boost converter?
No, they were happening before. I just didn't realize it because I was trying. Things just weren't working, and so I started measuring things. And I said, okay, let's add something to get the thing turned back on using the battery. I did that. And then when I put the breakout back into play, that's when I noticed the weird, the massive voltage drop from the battery to the output. The battery's pumping like 3.9 volts. The output of my breakout board, and I've got 2 or 3 of them, I've tried several of them, they're putting out about 2.8. So it's almost a whole volt drop after it goes through the board and comes out. So I don't know what it's doing. I haven't really looked too hard at it.
Do you have more than one of these, Harold?
Yeah.
Because just reading the reviews on Amazon, and some of them say they work great, but there's a couple of reviewers that say that so one guy said out of the 10 pieces, a few were defective. One kept draining the battery with no load attached. One kept on charging when the voltage exceeded 4.2 volts, and 2 were unable to provide usable power output, but worked okay for low
so
current.
What you're telling me, I should just try more boards because I got like 10, 15 of them. Okay, yeah. I can live with that. I thought I was doing something. I mean, I haven't messed with these things very much. I did a bunch of the research. And I'm like, okay, this seems like this should just work. And then when it doesn't, rattles in my head about, well, you've not done this before, and you should have checked this before you made all the stuff. And
I get it. But
all this stuff gets in your brain.
Out of a dozen reviews on Amazon, about 2 or 3 of them reported some number of them not working.
Okay, so I'll just rip through these things next time I go working on this, see if I can actually find a board. Because these, I mean, you're looking at what's the cost for 10 of these? You're looking at them right now, Paul. What's the cost on them?
Sorry, I switched from that tab. I'll tell you.
You buy them in like 10 packs or something like that.
Yeah, $7.
$7, 70 cents a piece, man. I figure something. I'm okay with the quality not being that great at 70 cents a piece, but I didn't know I needed to worry about that too much.
I would have gone where you went.
I figured I'm doing something wrong.
You're just driving the problem. Let me just check the reviews in case other people ran into that. And it looks like they did.
So it could be, I tried 2 different ones, so it could very possibly be, and they were probably 2 off the same batch of board that came out. So the chances are, if one of those didn't work, then the next one's probably high that it's not going to work either.
You may find, if you look at the solder job on the boards, you may find a fix as well.
Find what it is. I'll take a better gander at it. I've got a,
I don't
know, they're all surface mount, and I've got one of those microscope things that I can put under there and put the microscope on it. I'll do that.
Just a thought.
I'll do that. And so I got really frustrated. So we're going to set it aside while I was doing other things, and then come back to it after I had a chance. Because I will tell you, one of the things about Twitch streaming, me sitting here reading the manual and trying to go over data sheet specs to figure out what's going on with this board is some of the most thrilling Twitch streaming that you can ever possibly imagine. Yeah, Mike's been by my stream a couple times, and we have a pretty good time. Yeah, we generally have a pretty good time. Folks give me a hard time, and that's all right. We're just chuckling right along, and hopefully we're not breaking too much stuff and learning some stuff as we go.
All right. Any other discussion? New discoveries this week?
Harold, are you gonna be streaming tomorrow?
I'm planning on it, and as far as tomorrow goes, one of my subscribers spent 50,000 channel points. I call them CPU cycles, and he says when I do that, he gets to tell me what small project we're going to do. And there's something out there called Internet Time. And we've got one of my other subscribers who, Pong, when I go out to the Sin Shop out in Las Vegas, he's one of the people I hang out with. Fantastic guy. He's the one that gets me backstage at BattleBots, by the way. He knows all the people. And I'm like, okay, cool. So one of the things that comes up all the time is something called Internet Time. And I don't know if you ever heard about it, but it's called Internet Time, aka Swatch.BeatTime. So what the Swatch people did back in, I don't know, the 90s, 80s, one of those times, was come up with the metric version of time with no time zones. And what they've done is it goes off the Swatch headquarters in wherever that, Switzerland, wherever that is over there. And it's Swatch headquarters, that's 0 beat time at 0, and it'll go around the world once is 1,000 beats, and so it's basically the metric version of this time. And I've got this big, in fact, where is it? Yeah, I got a Raspberry Pi. I got some big 1.2 inch 7 segments, and we're gonna do a beat time on this. And as we're doing that, we'll eventually get up and model up something in a frame, put an acrylic plate over the front of it, and make it look real nice. And after I set it around here and make it work, we'll probably end up sending it to him, because he goes, if I would proudly show that on my shelf if I had that behind me all the time. And I said, dang it, you're ruining the surprise, man. We were going to do that anyway. We already decided to send it to him after we got it modeled up and sent out to the thing, but yeah, and I will tell you, as somebody else said as well, you just don't know how big 1.2 inches of 7 segment is until you get up close to them, because it's pretty substantial. I mean,
I'd never heard of beat time until you told me about it today. And you other guys haven't heard of
banana for scale. Banana for scale,
So, but you never answered my question. You said there was 1,000 beats in a day. Okay, I get that. So, and it's the same all around the world. So somewhere in Switzerland, I guess, is beat 0 for the day, or
for the day. And if I say I'm going to meet you at 500 beats, it's 500 beats for them, 500 beats for me, 500 beats for somebody else. Yeah, it's only 500 beats in a day.
But what you never explained was, okay, and I can see if we talk about, well, let's meet 2 days from now. We can say, let's meet 2,000 beats, maybe 2,500 beats from now.
From now.
But what you never explained was,
because I don't really understand it myself, man. I would explain it to you if I could, Paul. I promise I would. If you go look for Swatch beat time, you'll find a Wikipedia article on it. Okay. You'll even find a calculation how to take normal time and convert it to beat time. They have a conversion utility in there, all this other stuff. Of course, it went nowhere. I thought it was kind of neat, and the fact that we know this veritable cesspool of knowledge kind of stuff going on here. I figured I'd make him one of these things, and it'd be a fun thing to have around.
Do they have leap beats?
You see, why you got to be asking me stuff I can't answer now? You gotten hard already.
You
I'm
brought
sure
it up.
they're doing something. Now it is based. It is it is calculated off of UTC. So effectively, there's more than likely the leap beats are kind of factored in because there's leap years and leap things and leap stuff, but off the UTC universal time clock.
You technically don't really need leap beats because it's always relative to now.
Yeah.
Right? There's no way to there's no way to fix it to it's not even relevant to a year. It's just a passage of time in rotations of the Earth, but you don't say whether it's sidereal time or or if it's just the daylight time.
I don't know. We bring it up every now and then just to give him a hard time about it because he's the one that introduced it, and it's on it's one of these things where you're always poking him. Yeah, but how many beats is that? Give him a hard time.
So Kareem, it sounds like you know something about beats.
No, I'm just thinking this through on the fly.
Okay.
Just like
well, I'm just reading on Wikipedia, and it says what Harold said, but like I was born in 1956, so how do I express that
in beat time?
In beat time.
That's a lot of beats ago.
I could say how many beats ago it was, but that's not relevant because that number will change in one beat.
Yeah, that's the whole problem with making an entirely relative time statement. Although all time is only relative, so.
Well, not really. I mean,
yeah, we have some pretty artificial signposts based on what our Earth is doing relative to the sun.
But the Big Bang was really the zero of time, right?
I thought time started on January 1st of 1970. That's the epic.
That's right.
Epic, yeah.
It's Unix's zero time.
It's because we're linear type people. We had to construct this thing called time. If there's non-linear beings, which I don't know how that would work, but if there was, they wouldn't really care. They wouldn't know. So.
Oh yeah, that brings up a good point. What happens due to relativistic effects? Because as you go into as you leave the Earth, time slows down a little bit. So
do we get longer beats or shorter beats?
Time slows down, so you get longer beats.
Longer beats.
Did you see the article where they've managed to go send a laser pulse faster than the speed of light?
No,
I missed that one.
Yeah, there was something about lasers and plasma, and I believe it was 30% increase in the speed of light.
Yeah.
So if that
drag us into weird science, so to speak, right?
You got to be careful about that. I think that was just about a phase shift type of thing based on crossing into a different medium. It doesn't actually mean that light has sped up.
Right.
Oh, I think so.
And there have been some
flat earthers, we believe it.
There have been some techniques where people will get a wave going crossways across a waveguide as it travels down the waveguide, and they assert that since the wave is hitting the one side instantaneously at all points, it's traveled infinitely fast. But that's not true. What matters is the speed of causality, and the speed of light is the speed of causality, and I don't think you can go faster than that.
We keep hoping, but nobody's figured it out yet.
100 years ago, you couldn't go faster than the speed of sound.
Yes, but
There's
You know
something
what?
fundamentally different about the speed of causality, though.
You know what really kind of screws with my mind in this vein is the fact that the universe is only 13 million light years old. Sorry, 13 million years old, billion years old, but it's 80 billion years across, but nothing can go faster than the speed of light. How does that work?
Space can expand faster than the speed of light across vast distances. It's got nothing to do. It's got nothing to do with. There's no constraint on the rate at which space can expand. It's not the same thing.
If I'm driving my car down the highway at 60 miles an hour and I turn the light on, did that beam of light not travel 60 miles an hour faster than the speed of light?
No, it didn't.
No.
Does this mean, Kareem, that the officer, when they pull me over, I can say, but officer, I was going the right speed. It's the space that expanded. Or compressed, I guess.
Okay. I think we've lost the robots. Maybe it's time we
See,
call the break so they can come back and get back together.
derailed the whole thing again. That's something I do. Is Doug still online?
Yeah.
Yeah, Doug. I joined the club yesterday. I'm a member of the lab makerspace because I'm doing some stuff at UTD, and they really wanted me to be a member. And I looked in there, and they have some compelling reasons for me to be a member. Most notably, I want to get in some lathe turning, and I want to do a little resin action. And they've got some supplies there and some other stuff, so I don't have to buy stuff to try stuff to mess it up. But one of the things, because of this toy printing thing, my A1 was down, and I really need to print a bunch of stuff. My Ender 3, as good as it is, and I'm printing with it right now, it's just so much slower. And I fought with their X1Cs. They've got two X1Cs, and I'm sure this is all. I'm going to put this all on me because it was my expectations of stuff. I had to figure out a whole bunch of things I didn't think I had to figure out, and that's part of that. And part of that is how cardboard spools work in the AMS, and how everybody. And the frustration was, oh, they knew this was a problem. They just didn't bother to tell nobody. And I've had to figure this thing out and go through it, and driving up there at 4:30 in the morning. It's a 30-minute drive to and from. And after all that significant thing came down, Black Friday sales started at Bamboo on Monday. So I have pulled the trigger. I have eaten my own dog food where it comes to that, Doug. I have a Bamboo P1S with two AMSs coming to do fun stuff with.
Okay.
So I recommend that. And
you know how to handle the card. You know how to handle the cardboard spools now, right? Because
yeah,
inline has a lot of cardboard.
I've got some ideas, and even with some of those ideas, I was still having some problems. And I'm not sure whether I had actually found a solution, or because since it's a shared space in the makerspace, whether those things just needed a good cleaning and I would have been all right, or some other thing, and I wasn't prepared to do all that as what I needed to do. So, so I might have the solution, I might not. I did look online, and it turns out that the Polymaker, this filament I've been printing a lot with, and I don't know this for true. I'm just going to say there's a real similarity between the Polymaker cardboard spools and the inland cardboard spools. I mean, very, very similar. Like the key registers that the slip ring fits you were just talking about, they fit on most of those. Now, there's some of the inland that doesn't, because it's somehow they probably sourced it from a different brand or whatever. But I'm feeling pretty, either that's getting to be more of an industry standard thing on the spool type with the thing, or there's something going on there with Polymaker and Inman and Micro Center.
Okay, I got a couple of questions.
Okay.
You're familiar with the cardboard reel rim
Yes.
prints, because that's what they work perfectly. I just it's on the Bamboo site. You just print out a couple of them, stick them on there, and that takes care of it.
And I did find those, and that did help a whole lot. But I was still having other problems.
Yeah. The second question is, you're reporting the first Bamboo printer down that I've heard of. So what went wrong with your A1?
What went wrong? Okay. Well, I went wrong with my A1. What happened was I was printing with some marble filament, and it got a clog with the marble, and it's a 0.4 nozzle. I've done it plenty of times. In fact, I'm talking with some of the Loyal Moses people about marble on one of the channels right now.
Yeah.
And I said, yeah, because I printed with marble a bunch and I didn't have a problem. This time I did. And because I'd never tried to clean a clog and actually get into the tool head for the Bamboo, I was in unfamiliar territory and I assumed that I knew what I was doing. So I had some problems with it, didn't quite get the whole thing. And then I heard some sounds that weren't good, like extra snappy sounds that shouldn't have been snapping. You know how you get that plastic sound and you're pushing and all of a sudden you hear this pop that you shouldn't hear and you're like, oh no, that's not good. Well, I had a couple of those. Turns out, I don't know what it really caused, but it was nothing serious at all. And I thought it was really serious, and I was not. I was in a bad way, in bad state of mind, and so I let it sit. And Saturday, I did that on like a Tuesday or something. And then Saturday, I got up and I had a clearer mind. And I said, let's look at this. I ordered a bunch of parts. If anything that goes wrong with an A1, I got extra tool heads and extra other plastic bits and stuff because I wasn't messing around. I got it local. I'm happy to share. So that stuff actually came in today, but I've been printing since Saturday night because I took a second, took a step back, looked at some pictures more, worked at it a little bit better, and I said, wow, okay, because that marble clogged up one of the X1Cs, which I was surprised by that too. And how I unclogged the X1C. The X1C and the A1's different on how that tool head works. I was able to, and because it was a shared thing, I was pretty much forced to, we got to unclog this thing because I just screwed up a shared resource and I don't want to be the jerk that messes up everybody's printer, right? So I got in there and we got it going again using some needles and stuff, and it just went right out and it was fine. So I took all the marble out, I brought it home. I said, well, if I had to do that on my A1, and I did the same thing, and I was able to get the clogs out of it, and it was totally due to the extra little black bits that makes the marble so cool when it goes out. It was totally due to that.
Yeah, you might want to get yourself a 0.6 nozzle if you're gonna.
One of those is showing up tomorrow.
Okay. Yeah, I'm gonna say if you're gonna screw with all those additives, you need to go to 0.6 probably. Yeah. Let me ask you this. So did I hear you right? You got a P1S coming with 2 AMSs?
Yes, sir.
So you're not talking about the makerspace. You're talking about you. Okay. All right.
It was my wife is more. She did not realize this. She's probably way more intelligent than me, because she was saying stuff, and it took a little bit for me to and somebody else to actually point out something. So the makerspace is 30 minutes one way.
Yeah.
I was going up there on the way to work, way home back from work, make sure I changed prints and all those sorts of things, right?
Yeah.
John's shaking his hand over the head over there because he knows. And every time you go, you just don't come in and go click, click, click and leave. You got to go do other things, or there's something you need to take care of or something else. And so And also I was trying to keep the printer going. And sometimes these printers, sometimes the print ends at like 4:30, 5 o'clock in the morning. So I need to be there to change it out so nobody else pulls my print off. Okay. There's only 200 people in the lab makerspace in Richardson. There's only 200 members. But there's a couple of guys that work overnights.
Mm-hmm.
And I didn't want one of them rolling in there, pulling off my print and putting, keeping me from doing all the printing I needed to do. So I put that on myself, which made it more difficult. And I was really tired most of last week because I wasn't getting good sleep and all that kind of stuff. And so after doing all that, knowing how much gas, did a little quick thing in my head, how much gas, the time I'm away from the wife, the amount of stress that I had because I wanted to make some changes and do some upgrades. And hey, what about this upgrade? Oh, we can't do anything to the 2-year warranty's over. And I'm like, dude, you're a makerspace. What the hell? That's my thought. And so besides all, but it's community, it's not my property. So I'm going to do what the a makerspace asked me to do. And after seeing all that, the level of frustration, the amount of gas that I used last week alone, driving back and forth, because some of these days I stay home when I'm working, and the level of frustration and the amount of time I spent figuring these things out, because no one, even though they figured it out, didn't bother to tell anybody. I did the calculation on that on my hourly rate, and it isn't quite a wash, but it's pretty damn close. It's pretty damn close. I mean, the whole thing with some extra bits and bobs that I bought delivered with the shipping is about $1,250, and which is a pretty good deal as far as what I'm getting, price performance and that kind
What do they got the P1S at now?
of $549.
I mean, with an AMS.
$749. P1S with an AMS.
I got mine at, I want to say it was about $850. So they've come down another $100.
Yeah.
That's great. That so far I haven't had any problems with my A1S.
Yeah. I will tell you
It'll print anything.
Yeah, you got the X1C, it's got all the LiDAR and the AI and all that extra stuff. Having played with 2 of those for like almost the last week and a half. Not that they got in the way, I just felt that I don't need all of those things. If I was a makerspace like these folks are, I would certainly want those things because they would help more of the uninitiated not screw up things.
Yeah.
That kind of stuff. But I don't need that. I don't need the extra $400 or $500 of stuff that I don't. The only thing that I really want, and I think I could probably upgrade it, the camera on the P1S is not as good as the X1C.
Yeah.
And on the X1C, the X1C is passable, meaning it does an okay job. The A1 and the P1S make it so you can tell whether or not, something's busted or not. But
I would argue you can. Have you seen Aurora Tech's newest review of the new Persa, the MK4S?
No, I've not seen. I usually watch them. I love Aurora Tech. See,
Yeah.
that young lady is I want to say a pleasure to watch, but the way she delivers it and the consistency of their testing on everything they do, they're fantastic.
Yeah, well, I'll tell you what, it makes a pretty, Bamboo Lab has shaken up the whole thing. Okay, they definitely shook it up, but the new Persa, with they have a multiple spool changer thingy, which essentially doesn't create any poop.
Yeah.
Yeah, it does. You still have a tower, but it doesn't create any poop, and it looks like the reliability of it is just incredible. So that's something else. I don't know what the cost is. I didn't look at that, but that's but welcome to the P1S.
Yes. I think the cost on that is something like $3,000 or $4,000.
I don't
Something
know.
like that. It's really expensive.
Yeah.
And
Well,
I'm
I
like-
really enjoy my P1S, and I think you're going to enjoy it too. Don't break it.
I don't intend to break
shake,
it. You know?
You'll shake my confidence, Harold. I wouldn't have thought you could have broken in A1.
And the thing is, the only thing is because that marble, and I printed marble through a 0.4 nozzle on my ender a bunch, and I don't have a problem with it. And here, I just think I got a little bit unlucky with the filament size, the flake size getting in the wrong orientation as it tried to go through the nozzle.
Yeah.
That's what it only takes a little bit of that to hose up the whole world.
Is it a new spool?
Yeah, it's a brand new spool.
That's probably it. You might have got a bad one.
When I say brand new, this all this free stuff I got from Loyal in the parking lot. This is all Amazon returns. And when I say Amazon returns, this was new in the bag, vacuum sealed, the whole works. The only damage was to the outside box, and it had a couple of scrapes here and there. Some of the boxes are crushed. That's another thing too. Polymaker is down in southwest of Houston, and there's a pallet, 600 spools on a dock down there that they're going to have an event at some point. And I need to make sure I'm more noisy about this to share, because if we have any friends down in Houston, or if you want to make that drive, when that event goes down, they will be given. They're pretty liberal with their stuff. Like I say, I got 28 plus 28 usable spools from them. Now, almost all of them are allocated or gone to friends right now. But so yeah, that was, what would you do with 50 pounds of plastic to print with, which is essentially what I got.
Well,
that's a lot. That's a lot.
Yeah.
Well,
I'm sorry, I've started talking and going on and going on. I don't mean to take over the meeting. I think we lost a lot of people.
I think the meeting finished about 20 minutes ago.
Oh, okay.
So we're the only ones left. So
I will tell you, I don't want to take away anything from the DMS, but at some point, if you cats want to come over to the Richardson thing, and it's not as nice and it's not as necessarily capable as the DMS, because what makerspaces are, you're more than welcome to, and we can make some arrangements if you want, that kind of stuff. But no salesperson going on here. Just that's where I got friends over there doing stuff, and I got in there because of my work is wants to have more relationship with college students, and they have a relationship with UTD, and I'm one of their liaisons, so to speak.
So,
okay, well, why don't we turn the recording off, and we can continue chatting if we want, but I think we wound it down.
Yeah, I can wind anything down, man. I'm just